So hello friends, in today's video we are going to discuss the population inversion, which is a very important event you can say in the Erbium Doped Fiber amplifier or Erbium Doped Fiber amplification. So it is very important to know in details about the population inversion before discussing the working principle of the EDFA. So you can say the population inversion is a very important event um, which is happening during the ADFA, Erbium Doped Fiber amplification. So it is very important to know. So in today's video, we are going to discuss in details about the population inversion. Basically, the population inversion is the state or you can say the state in which the number of electrons in the metastable state is more than the ground state. So this is the main definition, or you can say that the situation which is known as the population inversion is where the number of electrons in higher energy state is greater than the lower energy state. So this is called the population inversion, and we will discuss in detail. So let's see population inversion. So I have made this diagram to explain the event of the population inversion. So let's see population inversion cannot be achieved in a two level energy system when we are using the 1480 nanometer laser diode. So when we are using the 1480 nanometer laser diode, there is only the two states. The first one is the ground state and the second is the metastable state. So when we are using the 1480 nanometer, there will be two states only, and hence the population inversion event cannot be achieved in this state. So, but to achieve the population inversion, we need at least three energy level. So, first one is the ground state, second one is the quasi-stable intermediate state or the metastable state, and the third one is the excited state, or you can say unstable short lifetime state. So you can see here population inversion can be achieved in a system where there are more than two energy levels. So when we are using 980 nanometer, there will be three energy levels. So the 980 nanometer wavelength photons have more energy than the 1480 nanometer wavelength photons. So when in alpha amplification, there are two types of pumps we are using 980 nanometer and 1480 nanometer. So I have made a separate video by differentiating the function of these two. So here you just need to know when we are using the 980 nanometer pump, the photon or you can say the electron will be jump for the higher energy state, then they get to metastable energy state and then ground state. So there will be three energy levels when we are using the 980 nanometer pump, and when we are using 1480 nanometer pump, there will be only two states. So the 980 nanometer wavelength photons have more energy than 1480 nanometer wavelength photon. That's why when the laser diode pumps the erbium ion with a 980 nanometer photon, the electron is in the ground state, even absorbs the sufficient energy and jumps directly into the excited state E3, you can see. The lifetime of electron in the energy state, higher energy state, or you can say the unstable short lifetime state, or you can say the lifetime of electrons in the level 3 or E3 energy state is 1 microsecond only, which is very low. So what happens? What happens after a short period of time, the electrons in the excited state E3 will fall into the metastable state A2. And here you can see here the lifetime of the electron is around 10 millisecond, which is very much higher than the one microsecond. So electron is rapidly decay from E3 to E2 and stay sometime on the E2. So when the electrons is releasing from E3 to E2, uh, it release energy in the form of heat, or you can say the non-radiating emission. The lifetime of electron in the metastable state or excited state E2 is greater than the excited state E3. So many electrons populated in the metastable state E2. What happens? The electrons absorb the photons when there is a 980 pump is used, and aerobium ion is excited with 980 nanometer of photon. It will directly jump into the E3 state and then move it after 1 microsecond to the quasi stable state, and here it is stay for the 10 millisecond. So what happens? The electrons uh, is moving from here to here very fast, and again from E3 to E3 in 1 microsecond and collects here. So what happens? So many electrons get populated in metastable state A2, and in such case, the population of the metastable state E2 is greater than the ground state E1. And this is the case, or this is the situation which is known as the population inversion. When there are, you can see here, the number of electrons in the metastable state is higher than the ground state. And this situation is called the population inversion, which is very important for the erbium doped fiber amplification. Thus, the population inversion, which is useful for light amplification, is achieved. So let's see, you can see erbium ER3 plus ion energy level diagram. You can see this is the ER3 plus energy level diagram. You can see here this is the energy level 1, level 2, level 3, E1, E2, E3. So this is the ground state, or we can say the E1. This is the metastable state E2, and this is the higher energy level E3. You can see this is the ground state, this is the quasi-stable intermediate state. Here the lifetime of the electron is 10 milliseconds. This is the unstable short lifetime state, or you can say the excited state E3, where the lifetime is 1 microsecond. So you can see whenever the 9 nanometer photon pump laser is injected, the erbium ion, you can say, absorb the energy and move from ground state to the excited state. You can see here this is the pump transition. This is the 980 nanometer pump photon is used. The erbium ion absorb the energy of 980 nanometer photon pump laser and move from ground state to the excited state E3. So let's see what happens. Fast non-radiative decay. You can see 1 microsecond. After 1 microsecond, this electron moves from E3 to E2. Here it is stay for 10 milliseconds. So you can see this is the spontaneous emission. What is meaning of spontaneous emission? What happens when the uh, electrons, or you can say the photons, absorb the energy, move from E3 E1 to E3, and when it jumps from E3 to E2 in the metastable state exists for some time, and what happens, some electrons automatically decay or lose their energy and move from E2, or you can say the metastable state, to the ground state. So this is automatically. So this type of emission is called the spontaneous emission. And here you can see this is with the 50 nanometer photon, but this is in random direction, you can say. And this spontaneous emission is the main cause of the, you can see the noise, as we hear about the noise. So this spontaneous emission is the main cause of the noise in the EDFA. So we will discuss in details in EDFA working principle. So let's see about the population inversion. So spontaneous emission happens automatically. You can see here from E3, E2 to E1. Now you can see there are 14 nanometer one photon. So whenever this erbium ion is injected, or you can say pumped with 1480 nanometer photon, it can directly move from ground state to the metastable state. There is no any excited state. So you can see here it jumps only from ground state to the metastable state. Now you can see what happens. The incoming photon signal, which is for 1550 nanometer signals. This is the signal which we need to amplify. So what happened, along with the pump laser, this the incoming signal is injected in the fiber. So when this incoming photon signal is interacted with the photons or the electrons in the quasi-stable intermediate state, so what happens, there are some same frequency photon is generated, and this is called the stimulated emission, because this emission is happened because of this incoming photon signal, 15 nanometer signals. So you can see when this photon interact with the photons in the quasi-stable state, so except these photons, one more photon of the same wavelength is generated, and this is called the stimulated emission, and this is how the amplification happens. So you can see these photons interact with the photons in the intermediate state, and one more light is injected. So in the same way, there are many photons, incoming photons interacted with a number of photons in the quasi-stable state, and the light amplification happens. And this emission is called the stimulated emissions. And in this emission, what happens, this wavelength the you can say the emitted photon is in the same frequency and phase of the incoming photon signal, and thus this photon signal, you can say this signal is amplified. So normally what happens, a system of atom is in temperature equilibrium, and here and there are always more atom in low energy state in the higher energy state, because every system just want to be in the stable state. So the most of the atoms happens in the low energy level, or you can say the ground state. Although absorption and emission energy is continuous process, the statistical distribution of atom in various energy state is constant. This is an important parameter. Emission and absorption is a continuous process, and so the statistical distribution means population of the atoms or electrons in various energy state is constant. So there are a number of electrons in the ground state, there are a number of electrons in quasi-stable and excited state. So this is all about the continuous process of emission and absorption. When the distribution is disturbed by pumping energy into the system, so there are some electrons in each system. So there is not only the three state, but there is a number of states happens in particular atom. So there are the distribution of electrons in the different energy system. But when this distribution is disturbed by pumping energy into the system, you can see this is the pumping energy. So when this distribution is disturbed, a population inversion will take place in which more atoms will exist in the higher energy level than the lower energy level. And this is the state which is very important for the amplification. So population inversion and pumping. If there are more atoms in the upper level N2 than the lower level N1, the system is not in thermal equilibrium. A situation not equilibrium must be created by adding energy by a process known as the pumping. So this obviously the number of electrons want the system, because a system wants to be in stable state. So number of photons or electrons be in the ground state. But when the number of electrons in the higher energy state is more than the lower energy state, it means there are some extra energy or external energy is given to the system. So this is the meaning. A situation which is not at equilibrium must be created by adding energy via a process known as pumping in order to raise enough atom to the upper level. This is known as the population inversion, which is given by delta is equal to n2 minus n1. N2 is greater than n1 and there is a delta, means this is the positive, means n2 minus n1, the number of electrons in quasi-stable state is greater than the ground state. So this state is known as the population inversion. Light is amplified when the population inversion is positive. Pumping may be electrical, optical, or chemical. So this is all about the population inversion. Thanks for watching.